No. Work with me. All right. All right, guys. So the test, of course, is this Thursday. So just to remind you guys, some of you still need to get your quizzes back. I think you're going to get them today. And tomorrow, the corrections for those will be due Thursday. All right. Corrections are always due by the day of the test. You can give them to me after the test. So like you give quiz 1 corrections, you can give me on the day of the final. You're not going to get anywhere near as many points, maybe no points. But, if you got all the corrections right, you might get a point. Does that make sense? It's late. So the number of points you get back goes down the later it is. Okay. All right. So last time I think we did the first... This one about mowing the lawn? Yeah. Very excited. So this one here, my colleague Beth, she's my office mate, Beth Smith, and Bill Bradley used to be our dean. So I think I'm in here somewhere. Jeff is doing something, I don't know. So this one is more classic word problem because if you read through this, something depends on something else. Do you guys see that? So really, what's the first step in a word problem is not mathematical at all. You guys think you're supposed to read it once and then be able to set the equation up. That is insane. No wonder you think math is hard. Holy crap, that would be hard. Your first step is just English. What are the players in the problem? Well, here it's very in your face. What are the players? What about them? Best time, Bill's time, right? To build these trails. Unfortunately, they both start with the letter B. I normally try to use letters that correspond to something in the problem. So let's see, Bill can build one section in 15 hours less time than Beth. Holy shit, Bill. Demon. So which one is going to be just a letter? Yeah, because Bill's time depends on Beth's time. Right? So that should be something you're coming out of Mac 90 with, is the ability to find out which one is just X or whatever. So let's just use X. So Beth's time is X. And now I can build Bill's time off of that. So this is not just something that we do to you to make you go crazy. It's modeling the real world using tools that humans created. Holy shit. So I need to model this problem. Why don't I give them both separate variables? Well, one, that would make this disgusting. And two, there's no reason to, because one is based on the other one. We're going to model this. Best time, whatever best time is, Bill's time is going to be that minus 15. So if I call Beth X, I can call Bill's time X minus 15. Working together, they can build it in 18 hours. So how do I set that up? We did that yesterday. Beth can build one section in X hours. Bill can build one section in X minus 15 hours. Together, they can build one section in 18. The first problem, we knew these two things, we didn't know this. That was a little bit easier. This one, there's two things I don't know. Shit. There's really just one thing I don't know, because once I know that, I know the other thing. You guys finish it up. Do it. The practice test or this thing? No, I think I ran out last time, so.
Okay.
Yep. You just have to put what you can down from here. By the way, guys, it's becoming a bigger hassle than I thought to try to get this book thing put together. So I'm just going to keep printing out the chapters and giving them out in class like I did. That way you've already paid enough money for shit, man. My math lab is like, give me your money. I'm sorry about that. So at least this I can give to you. Why the hell not? Just make sure everybody's on the right track. What number do they all have to have? There's only one number, so they all need it. This guy needs it. This guy needs it. This guy's got it. Cool. What's this first guy missing? X minus 15. What's the second guy missing?
X.
X. This is the times. What's his last guy missing?
X.
So now, of course, is that cool right there? I mean, let that be cool, really. You're just giving the parts that are missing stuff compared to the other guys, being fair. That feels nice. Normally math seems to be this evil thing, especially where I teach you killing things, which we're about to do. But right now we're being nice. Everybody gets some stuff here. Everybody got the same. So now I can kill everything now, right? All the bottoms? They're all the same, so I can multiply both sides by 18x, x minus 15. Bam, 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 bam. So what's left? What do I have up here?
18x.
270 plus 18x equals x squared minus 15x. All right, keep going. This is yummy. Yeah, keep going. No, don't tell me out loud. You go on your paper. Good. Question? Good? Okay. Yes. Again, I gave this first guy 18x minus 15 because he was missing those things. I gave this next guy 18x because he was missing those things. I gave this last guy these because he was missing those. The bottoms cancel, I end up here. Why was I allowed to kill the denominator and denominators? Why?
They're the same.
No. Why was I allowed to kill them? Because they are in an equation. You can't just kill fractions just standing there being all innocent. If they're in an equation, you're allowed to. Because then you have balance. You were the chosen one. So. Now this is just too yummy to believe. You got to get two numbers that multiply by 270 and add to be 51. Negative, both be negative.
Oh, so negative 20, or negative 54 and 5.
Negative 54 and 5?
Instead of, and positive 5 is negative 51.
No.
Yes.
55 and 4 would give you. Yes.
Oh.
So let's see, negative 45 times 6. Yeah, negative 6, exactly. So, again, guys, yes.
Why is just positive 270?
Because you add it. You see the arrows? So I subtracted 36x, added 270 to get them over to the other side. And again, what told me to do that?
X squared.
Yes, there's an x squared term. I got to get it equal to 0. You got to realize when the problem is saying, hey, this is how you solve me. Good Lord, you're going to love that shit, right? You got to love that. Normally, they don't tell you anything. And this is the step you all hate so much, but is everybody cool with the fact that they have to be the same sign?
Yeah.
So they have to add to 51, not subtract to be 51. So just pick some shit. Let's see, 20 and 31, they make 51, right? But when you multiply those, you don't get 270. You get 6, holy shit, you get 600 something. Okay. So let's try negative 10 and negative 41. That makes 51, right? So this is like negative 600 something, right? When you multiply these, you get negative 4. Oh, I'm going in the right direction. Going in the right direction. You guys understand what I'm doing right now? Do you understand? If you don't, you really should ask.
I got the answer.
Oh, yeah.
6 and 45.
There you go. That's what you got up here, right?
Yeah.
So eventually you get this negative 6 and negative 45. Because again, I've said this before, you're just trying to find two numbers that do two things. Who cares which one they do first? These do one of the things, not the other one. These do one of the things, not the other one. These do both. Yay. So then how do I factor this? So you get x equals 6. Now there's a problem with one of these answers. It's not immediately obvious, yes? No. One's too small. You got to be careful. The total number of vowels is 18, which means one of them is going to be, like, they both have to be around 18. I mean, they just have to, does that make sense? You have no idea how big or small either one is, because they're going to be working together. So 6 is not good. Why is 6 not good? Because if best time was 6 hours, what would Bill's time be? Negative 9. So 9 hours before he got there, he was done. What? Again, math doesn't know that this is a real world problem. Math is like, this number works, and we're like, that's nice, math. That does not make that in the real world work. So we throw that shit out. So X is 45. Best time is 45 hours. And Bill's time is 30 hours. So Beth working alone could have done it in 45. Bill working alone could have done it in 30. Together they do it in 18. Okay. Anything about that problem? You guys okay with that problem? Okay. So, we're going to leave behind the work problems, right? Those were work problems. You can see them very easily. It takes this one together. Okay, that's telling me it's the 1 over something plus. I can tell when to do that. That's a work problem. This is not a work problem. What kind of problem is this? It is a problem. Yeah, say it again.
Distance equals rate multiplied by time.
Ooh, dude. The good old dirt, right? D equals RT. Dirt. Distance equals rate times time. You guys use that formula all the time without thinking about it? Trying to estimate how long it's going to be before you get somewhere when you're driving on the road. I'm sure you try to do that, right? Or your little GPS tells you shit now. Yeah, well. Change comes out automatically. GPS gives you. Nobody knows numbers anymore. All right. So the main idea behind this problem is distance equals rate times time. I'm going to give you a method, you've probably seen it before, that just kind of helps us organize stuff. You see how there's two things going on? In this case, there's two people. In general, it could be one person going somewhere and coming back. So that would be there and back. Right? Like the hop. There and back. So what I can do to kind of organize this stuff, set up a little chart, dude. Not the only way to do this, but it's a nice organizational tool. What are my two things going on? What are my two situations? Sharon? And sure. Again, those are two of my colleagues. Sharon bikes 15 kilometers an hour faster than Shirley does. And the time it takes Sharon to travel 80 kilometers, Shirley travels 50. Which boxes can I just fill right in? What do I know for sure? Definitely no algebra required. Sharon went how far?
50 miles.
No. Sharon definitely went 80 kilometers. So I could put a number right there. Look at that. That feels good. We know that Sharon went 80. And how far did Shirley go? 50. Now where's the algebra got to come in? Now, Kara, I'm catching up to you. Sharon bikes 50 kilometers an hour faster than Shirley does. So which one of them is going to be just X? Yeah. Sharon is related to Shirley. I got to know Shirley first, and then Sharon is 15 faster than that. Now, the key to this to work is to not fill in too many. You're supposed to fill in 4 of them, so you got 2 left open. What's the formula say? What does mine say? D equals RT. So how do I figure out the time for Sharon? If D is RT, what's time? Let me do it for you. There you go. Time is distance divided by rate. So what do I put here? 80 over x plus 15. So like, for example, if you have to go 10 miles and you're going 2 miles an hour, how long will it take you? If you got to go 10 miles and you're going 2 miles an hour, how long will it take you? 5 hours, dear God, please be. 10 divided by 2. Distance divided by rate is time. Not because math said so, because it is. And math just kind of models that fact. So equations don't set facts. Facts set up equations. If equations set up facts, it'd be so cool. Math people could just make an equation and change. When I was a little kid, I thought you could do that. Just to tell you something I've never told anyone. I thought you could make an equation and things would change. And that's a little insight into weird-ass Jeff. What do you put here?
50 over X.
Yeah, distance over rate, 50 over x. Now, here's the little bit hidden thing. The last boxes you fill in will normally be where the equation comes from. How do their times relate? It's kind of a little bit hidden. What's the only thing they really say about time in the problem?
It's the same.
It's the same.
In the time it takes Sharon to travel, Shirley. Okay, so it's the same. So this has to equal this. I mean, that just makes sense. It looks gross because there's stuff that we don't know. So of course it's going to look gross. So 80 over x plus 15 has to equal 50 over x. Now, we haven't really talked about this yet. There is a process you guys love too much and you try to use it too many places. Yes, what am I allowed to do here? I can cross multiply. When's the only time it actually works is when I have one fraction equals one fraction. If you try to use it anywhere else, you're going to mess up if you're not careful. You can actually use it in more places, but you can't use it exactly the same way. It's a little bit of a clever thing to do. So don't. This is the only time you can use it directly. And really, it's a shortcut. Watch this. I'm gonna do this long ass way, okay? And I'm still gonna have people sitting there saying, "What the shit is he doing?" And I don't care. What would I do? How would I solve this the old way? What's this guy missing?
X plus 15.
X plus 15. What's this guy missing?
X.
And then I would kill these. So what does it look like effectively happened? Let's make a shortcut. That looks like it came up there, and that looks like it came up there. Okay, we'll do that from now on. That's it. It's the exact same thing we do. It's just a shortcut of what we do. So that comes up there. Why? Because that's what it looks like it does. And that comes up there. Why? You guys understand that? A lot of people can do that. A lot of you can do it too good because you try to do it everywhere. But I find sometimes people don't know why it works. You should not be okay with that. All right, and then how do I finish this out? Yes. Yes. So 80x equals 50x plus 750. Subtract 50, you get 30x, divide by 30, you get 25. What's that mean? Shirley's going how fast?
$25.
25
Yeah.
light years per second? Kilometers per hour. And Sharon's going how fast? 25 plus 15, 40 kilometers per hour. Circle. That's your answer. I'm not saying this is easy. I'm saying that every step you take to do this makes sense if you let it. It has to make sense. If you're doing something that makes no sense, stop. And you're all like, then I wouldn't do anything. Stop. Let's see. You guys try this one. I'm going to give you a little hints about this one. Tugboat normally goes 12 miles an hour. Upstream and downstream, right? How fast is the stream going? That's what we don't know. So when it's going, you guys okay? You understand what upstream means? Is it going to be going faster or slower if it's going upstream? Slower. How much slower? It's going to be 48 minus some amount, minus x, because I don't know how fast the current is. If the current was 48 miles an hour, this is all miles. The current was 48 miles an hour, and I'm pushing it 48 miles an hour. I'm just sitting there. Everybody on the bank's going to be like, it's like those kayakers that get the right and they're just sitting in place because they're matching the speed of the stream coming at them. Same idea. Or if you're on the airport conveyor belt and you walk backwards against it, you can stay in the same place. And everybody coming at you is like, what the shit are you doing? I'm bored, man. Got to leave. Lay down that shit. Sorry. So the current is X. That's all I'll say. Try to do that problem. Try to set it up. Real quick, did everybody get a practice test? Anybody sneak in? Not get a practice test? Practice test. so this is not always true, but again, I can just put the distances in there, right? They're both 48. Just make sure everybody's right here. Upstream, they're not going 12 mile an hour, they're going 12 minus x. And I think earlier I said 40, I'm sorry. I looked at the wrong number. They're going 12 mile an hour normally, but now they're going to lose that much speed by the current, right? So downstream, they're actually going to be going faster, so it's going to be 12 plus x. All right. So try to finish that. Oh, what's up? What happened? All right, now listen. All right, here I am walking in the airport, right? Let's say I'm going, I don't know, 2 feet per second. And let's say the little, what do you call it, conveyor belt thing is going, let's say that's going 2 feet per second. You with me? So if I get on that thing and I just keep going myself the same speed I was, how fast am I actually going? 4 feet per second. I'm going 2 feet per second, but the thing I'm on is also going 2 feet per second. Please don't look at me like that. If you keep walking the same speed you are, and you get on the belt, and you keep walking the same speed you were, how fast are you going based on somebody standing there? 4! Okay, thank you. Dear God. If I turn around and start going 2 back, I'm actually going to end up doing some really lame-ass attempt at a moonwalk. Sorry. Right? I can't do that. I'm not going to try. You guys, so we have a 2 minus 2 going that way. So 2 plus 2, because I got 2, the belt's got 2, we got 4 together. Oh, if I go against it, 2 minus 2, I'm standing in place. So here, 12 by the boat itself. It's going against the current. It's going to lose some speed, minus x. The current's pushing against it. It's going with the current. It's going to gain some speed, the same way I did on the freaking belt, right? It's the same stupid thing. And again, we know that happens. You've done it before. But this is what it looks like mathematically, which is not always immediately obvious to us because that's not how we think automatically. What do I put here? Who? If you put 9 here, why is that wrong? Total of 9. That's going to be where the equation comes from. How many boxes are left unempty? How many boxes are left empty? 2. So then I use the equation to fill them in. Same way I did earlier. Time is distance divided by rate. Now what are these 2 times supposed to do? It was a total of 9 hours. So whatever the first time is, if I add it to the second time, it better come out to be 9. That sounds like an equation, right? Go ahead and finish that out. So what's this first guy here missing? Who? 12 plus x. What's the second guy missing? See, I think some of you guys, understandably, you don't trust the process. You try to control or think ahead to what's going to happen or something, but I don't care what the hell's under those things. I give them all what they're missing relative to the other. It doesn't matter what the hell it is. Just give it to them. So what's this last guy missing? Freaking everything. Poor little dude. So then again, I can kill the bottoms because it's an equation. I can multiply both sides by that bottom. Now I just distribute. Oh, what's that going to be, Jeff? 96. Is that right? 9 times 144? 1296? So there you go. Just to cut to the chase. If you FOIL this, you get 144 minus x squared, and then you distribute a 9 through, you get here. Oop, you need a 9, Jeff. There you go, buddy. Now again, do you have to be able to do what I just did? No. You multiply this out, and then you distribute a 9 through, and you'll get here. What's happening? What happens on this side is nice. 576 plus 576 is 1,000. Sounds right. Equals 1296 minus x. Yeah, I keep forgetting my poor little 90. And then you can subtract this over, so minus 1152. That's 144, freaky. What is this? See, there's something I want you to understand. I had no idea this is going to end up here. I had no idea this was going to end up here. I just let things happen and deal with them as they come. I think some of you guys trying to force certain things to happen or feel like you're supposed to do more. No, you just let shit happen. Yes?
Can you move the negative 9x squared to the other side?
Sure. Doesn't matter. It's going to be the same answer. So here I get 144 is minus plus 9x squared is. So we got x equals 4 or negative 4. Are both of those answers okay? Considering x is the speed of the current. Yeah. No, it's not. They're not both okay. I can't be going no negative speed. I can go negative velocity because that has direction, but speed is pure how fast you. If you're going negative 4, you're sucked into a different dimension or something. And I don't think that's a part of this problem. I don't know, Rick. Responsibility. So, what does this mean? Let's see if anybody gets my references. What does this mean? Is this an answer, actually? This isn't even an answer. This isn't. What's my answers? Upstream. What's the speed of the current? Well, this is an answer, but what is it? X equals 4 miles per hour. I like it. It's the speed of the current. Whoa, there it is. It doesn't make physical sense? Yeah, it does. I'm left with 8 and 16, yay. Okay, good. So just looking at the practice test real quick, in the last few minutes. Oh, yeah. Why, Jeff? This guy. And then the nicest looking one is actually, fractions, right? But come on, you guys have got to get over your aversion of fractions. You just got to. Here, be careful. I say graph it and give it an interval notation. This one is interesting. Number 3. Perpendicular. Who remembers what perpendicular lines, what's true about them?
They intersect.
They intersect at a 90-degree angle. What's more useful to know? Their slopes have to be
Negative.
completely opposite. What do I mean by that? I mean, how many opposites are there? Different signs, flipped. So that has to be negative reciprocals. If one guy's slope is 1/3, the other guy's slope has to be -3.
Yeah.
Okay, so let's make sure you guys remember that when you try to do this problem. Perpendicular means totally, like total opposite slopes. Totally. And then this is all normal stuff here. And this is all normal stuff. This is that nifty fracception stuff. Ooh, and then functions. Yeah, baby. You should add some function questions in your chapter 1 through 6 review stuff. And then finally, there's our good old distance rate time problem right at the end. Yay. Okay. If you're going to the lab, just kind of walk slow. We're early. Don't invade them right yet.